recognizing me. Hi, I'm Ethan. Hi, I'm Miss Isaac.
Hi, I'm Miss Hall, and this is Lesson 63, Sum of a Finite Arithmetic Series. Finding sums of finite arithmetic series. The expression formed by adding the terms of an arithmetic sequence is called an arithmetic series. The sum of the first n terms of an arithmetic series is denoted by S sub n. To find a rule for S sub n, you can write S sub n in two different ways and add the results. The top equation, S sub n, is the first term plus the first term plus the common difference, plus the first term plus twice the common difference, plus the first term plus 3 times the common difference, all the way to our final term, A sub n. The second equation is the sum of this same series, but written backwards. So you start with the final term, and then you take the final term minus the common difference, the final term minus 2 times the common difference, and so on, all the way till you get to the first term. In writing it these two ways, what happens is now we can add these equations together, and you will get two sums of the series equals the first term plus the last term, plus, and you'll see that these d's cancel out, the first term plus the last term. And these two d's cancel out, the first term plus the last term. And so on and so on. A total of n times. And you end up with that, if you were to add the series twice, it would be the first term plus the last term. And so when we want to know the sum of an arithmetic series, here we can divide both sides by 2, and we'll end up with this given formula. Okay? You do not need to be able to derive it. I wanted to show you the origin of this. What you need to do is be able to apply this arithmetic series formula, okay? Which is that the sum of an arithmetic series is the number of terms times the first term plus the last term divided by 2. Example 5, finding the sum of an arithmetic series. Find the sum. So we're going to be adding the first 20 terms because the index goes from 1 to 20. And the rule is 3i plus 7. So there are 3 important things we need to know. We need to know the number of terms, which is 20. We need to know the first term and the last term. Because there's 20 terms, the last term is the 20th term. Okay, for the first term, that means I is 1. So it'll be 3 times 1 plus 7, which is 10. And the last term, it'll be 3 times 20 plus 7, which is 67. Now I can plug it into the formula. So the sum of the first 20 terms is going to be 20 times 10 plus 67 all over 2, which is going to be 20 times 77 over 2. And at this point, I can just put it in a calculator, and I will get 770. Example 6, solving a real-life problem. You are making a house of cards similar to the one shown. A, write a rule for the number of cards in the nth row when the top row is 1. Start there. So, make a table. So the top row has 3 cards. They've circled it. The second row has 3 cards. 3 cards has 6. The third row, 1, 2, 3 triangles, so that's 9, and so on. Okay, this is enough for me to write the arithmetic rule. The y values, or the sequence, is increasing by 3. So I know it's going to be y equals 3x. And let me just see if I have to add or subtract anything by plugging in. 3 times 1 is 3. 3 times 2 is 6. No, there it is. I'll write it in a sub n form, but it's unnecessary. A sub n equals 3n. I wrote myself a reminder up here that when you have an arithmetic sequence, you can also use the arithmetic sequence formula. I tend to default to y equals mx plus b because it's what I'm most familiar with. But it's okay if you use that formula, and if you do, you get a sub n equals the first term, which is 3, plus n minus 1 times the difference, 3. And if you were to distribute that 3 and combine like terms, you would get my answer, a sub n equals 3n. This is also a fine answer. Part B. How many cards do you need to make a house of cards with 12 rows? Okay, so now I'm thinking of the summation notation. We're going to be going from 1 to 12. And I'm going to use my rule, 3i. Again, you could use either rule. So I need n, the number of terms. I need the first term. I need the last term. 12 items. The first one is 3 times 1, which is 3. The last one is 3 times 12, which is 36. The formula, the sum of the first 12 terms will be 12 times 3 plus 36 over 2. And when you simplify that, you get 234 cards. So here's your real-world problem. In the real world, when you look to build a house of cards, one way to figure out the total amount of cards you need is to create a sequence with a rule, and then find the sum of this series, and you will get 234 cards.